Hi everyone, today we're going to be talking about arithmetic series. So in my previous video I talked about what an arithmetic sequence was, and an arithmetic sequence is a sequence created by addition or subtraction. So just to go over that, so for example, an arithmetic sequence would be something like 3, 5, 7, 9, and so on, because you add 2 each time. And an arithmetic series is a sum of an arithmetic sequence, so it would be like adding 3 plus 5 plus 7 plus 9 and so on until a certain number. So I'm just going to try to derive a formula, because last time we had the formula an equals a1 plus n minus 1d for the arithmetic sequence formula. But what about if I wanted to add each number in the sequence and find this formula for an arithmetic series? So, for example, let's say we have this sequence, 3, 5, 7, 9, 11, and 13. So how would we go about adding that? Well, we could do 3 plus 5 plus 7 plus 9 and go on. But another easier way to solve this would be to look at some patterns. So we have 3 and 13 on the outside. Well, if we add that, it's going to be 16. And then we have 5 and we have 11. And if we add that, it's also going to be 16, and 7 and 9 is also 16. So a quick way to add this up would be to do 16 times 3, which is 48. So we can use this idea to create a formula for an arithmetic series. So what we were doing here is we were adding the outside numbers, and we got 16, and the outside numbers also equal the two inner numbers and then the inner numbers. So we have a1 plus an, because a1 is 3 and an is 13. And then so this is going to be this 16 right here. And then we're multiplying that by 3, because we have 3 16s, and that's because in this sequence of 6 numbers we have 3 pairs of numbers. So we have 1, and then we have 2, and then we have 3. So we have n over 2, because n is a number of numbers in the sequence. So we have 6, and we're dividing that by 3 because we have 3 pairs, so we have a total of 6 numbers. So the sum of an arithmetic sequence, or an arithmetic series, this is a formula. N over 2 and multiplied by a1 plus an. So we just derived the formula. And if we want to see how this would come up with this, so n would be 6, because we have 6 numbers in this sequence, over 2, a1 plus an, 3 plus 13, and then we get 3 times 16 is 48, so we do get 48 either way. But let's say, in this case, we had 6 numbers, so it was even, so we had 3 pairs. But what if we have only 5 numbers in the sequence? So for example, 3, 5, 7, 9, 11. Then we don't have enough numbers to create equal pairs. So we have 14 here, and then we have 14. And then we're just left with 1 7, and 7 doesn't pair up with another 7. So how would we derive a formula for this one? Well, in this case, we do a1 plus an, the same thing. We do a1 plus an. And in this case, we have 5 numbers, 1, 2, 3, 4, 5, but we only have 2, and that's because we're eliminating this middle number, and then so we're subtracting, so we're doing n minus 1 over 2. Because in this case, we have 5 numbers in the sequence, but we're subtracting the middle number, so we only have 4 numbers, and we're dividing that by 2 to have these 2 numbers right here. But then we also need to add this number into the sum, because we're not just going to skip that number. And what we realize is that 7 is the middle of 3 and 11. So how do we find the middle? Well, we go 3 plus 11 divided by 2. So then, okay, so 3 plus 11, so 3 plus 11, but that's also the same thing as a1 plus an over 2. Sorry, I'm just not going to write the numbers in there. So if we were to add this up to create a formula that's more simplified, we have n minus 1 over 2, a1 plus an, plus, and we have 1 over 2, a1 plus an here. And then here we can just add this together, and we have n minus 1 plus 1, and then a1 plus an over 2. And then if we have this, we can subtract, where we can do negative 1 plus 1, which is just 0. So we have n a1 plus an over 2. So that's basically the same thing as what we got right here. So that means that this formula works no matter how many numbers there are in the sequence. Okay, so now we're going to use this formula right here and use them to solve some of these problems. So find the sum of the first 12 terms in the sequence, 2, 4, 6, dot, dot, dot. So I'm going to write the formula here, Sn equals n over 2, and then a1 plus an. So in this case, we know what a1 is. a1 is just 2 because that's the first number in the sequence. And we know what n is. That's 12 numbers. We want to know the first 12 terms in the sequence. And then we also want to know an. And an, we don't know it straight away, but we can remember the formula we used before, which is a1 plus n minus 1 times d. And then we can try to solve for an first. So we know that a1 is 2 plus, and we want to find a12, so I'm just going to put, that's the same thing. So then we have 12 minus 1 times d, and d is going to be 2 because we're adding 2 each time here. And then I'm going to solve for a12, and that's going to be 2 plus 11 times 2, which is 2 plus 22, which is 24. So we have a12 is 24. So here I'm going to write the sum of the first 12 terms in the sequence is going to be 12 over 2, and the first number in the sequence plus the last number in the sequence, which we solved right here, is 24. And then I'm just going to add this up. So we have 6, and then we have 24 plus 2 is 26. And then this is 156. So the sum of the first 12 terms in the sequence is 156. Okay, next problem. Find the sum of the sequence -8, -5, -2, and on to 7. So in this case, we know a1. a1 is -8. And then we know an is 7. But what we don't know is we don't know n. So I'm just going to write the formula here. The sum is n over 2a1 plus an. So we just need to find out n. And in order to do that, we can use the formula we used before. An equals a1 plus n minus 1d. So we know the last number and we know the first number, so I'm just going to plug that in. So an is going to be 7. a1 is going to be -8 plus, and we want to know what n is, so we want to know how many numbers there are in this sequence, times d, and d is just going to be +3 because we're adding 3 each time in the sequence. So we have 7 equals -8 plus 3n minus 3. And then we have 7 equals -11 plus 3n, which is equal to 18 equals 3n, and n is 6. So then I'm just going to plug everything back in this formula. So we have n is 6, we just solved for that right here. So we have 6 over 2. And a1, the first term in the sequence, is -8 plus, and then the last term in the sequence is 7, so it's 7. So we have 3, and -8 plus 7 is -1. So the sum is going to be -3. So when we add all these numbers up, we're going to get -3. Okay, so now we're going to try some word problems. And this first word problem I found on this website called regentsprep.org. Okay, you visit the Grand Canyon and drop a penny off the edge of a cliff. The distance a penny will fall is 16 feet the first second, 48 feet the next second, 80 feet the third second, and so on in an arithmetic sequence. What is the total distance the object will fall in 6 seconds? So we know that the first second we have 16, second second we have 48, 80, and so on. So we want to know the total Sn when after 6 seconds, so basically S6. So I'm going to write the formula here, n2a1 plus an. So we know a1, a1 is going to be just 16. We know n is going to be 6 because we want to know how far the object falls after 6 seconds, but we just want to know an first. So I'm going to solve for an right here. and we want to know A6, so we want to know the distance it falls at the 6th second to finish this sequence. So we want to know the last number of the sequence. So we have A6 equals A1 plus n minus 1 times d. So A1 is 16 plus n minus 1, so 6 minus 1 is 5. And d, how much is this increasing by each time? So I'm just going to do 48 minus 16, which is 32. And then I'm going to do 16 plus 160 equals 176. So that means it goes 16, 48, 80, blah, 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 until 176. So then I'm just going to plug all these numbers into this formula because I want to find the total distance the object is going to fall. So we have 6 over 2, and A1 is 16, and AN is 176. And then I'm just going to solve this. So 3, and we have 12, 9, 192. We're going to multiply that together, so we have 6. Sorry, I'm going backwards. Okay, so 576 meters is the total distance the object is going to fall after 6 seconds. So what we just did here was we found the sequence, and then we wanted to find the last number so that we can use the formula. And then we're going to add all of these numbers. And instead of just adding them on a calculator or anything, I just did it through this formula. Okay, so next problem. You decide to start saving up your money. On the first day, you put $1 in your piggy bank. On the second day, you put $2. On the third day, you put $3, and so on. How many days until you have a total of $2,211? So on the first day, you have $1. On the second day, you have $2. On the third day, you have $3, and so on. And you want to know, and instead of finding the total, this time they give you the total, and they want to know how many days it's going to take. So we want to know SN. Oh no, sorry. SN is 2,211, and we want to know N. We know A1 is 1, and we don't know AN yet, but we could solve for that by using this formula: A1 plus n minus 1d. So we know that A1 is just 1 plus n minus 1 is what we want to find. We want to find n, and then we know d is at 1 because we're adding 1 each time to this formula. So we have 1 plus n minus 1, which is just n. So an is n. So I'm just going to use the formula. So we have Sn equals n over 2 a1 plus an. And the reason why I had to solve for an, and the reason why an could also be a variable here, is because we're looking for this variable. So if I plug this in right here, and I have 2, 2, 1, 1, and I have n over 2, and I have a1, oh, sorry, I know what a1 is. a1 is just 1, plus n. Because if we had left this as an, then we would have to solve for 2 variables, and that wouldn't really work, because we can only solve for 1 variable with 1 equation. So in this case, I just switched this to this, which I solved for right here, so that I'm only dealing with 1 variable in this equation. Okay. So then I'm just going to solve this. So I have 2,211 equals, okay, so first I'm just going to multiply 2, sorry. I'm going to multiply 2 first. And then I have n, 1 plus n. Okay. Then this is going to equal to 4, 4, 2, 2 equals n plus n squared. And then I'm going to rearrange this, and I have n squared plus n, and I'm subtracting 4,422 on both sides, equals 0. And then I'm going to solve for this, which is equal to n minus 66, n plus 67 equals 0. And I have n equals 66 and negative 67, but you cannot have negative days, so I'm going to go with 66. So the answer is it's going to take 66 days until we have $2,211. Okay, thank you for watching, and I hope you enjoyed this video.